In section 5.5, we're looking at inequalities in triangles and a visual example to start with. I'm going to take a look at this triangle, find the largest angle, and find the longest side. And then find the smallest angle and the shortest side. What's the relationship between largest angle, longest side, and smallest angle, shortest side? Well, largest angle or biggest angle in this triangle would have had to be here, right? And where's the longest side? Well, this is definitely the longest side. In red, where's the smallest angle? Well, this is the smallest angle. And where's the shortest side in this triangle? Well, this is the shortest side. What's the relationship here? And hopefully you noticed, look at that, they're opposite from each other, right? They're across the triangle, are opposite from each other. But doesn't that kind of make sense? I mean, the bigger that you open this angle, the bigger the side opposite from it. And the smaller the angle gets, the closer together these line segments will be at the end, meaning the side will be very short. That relationship stands in any triangle. The bigger the angle, the bigger the side opposite. Smaller the angle, the smaller the side opposite. Now, the way your book writes these theorems, you have two separate theorems stating these. I would much prefer this. It summarizes it. So if you're looking at what to write in your notebooks, I would say write this down. Okay. I just want to read what your book says. They say in this theorem, if one side of a triangle is longer than another. Okay, so you have one side longer than another. Then look at the angle opposite from the larger side, and that angle is going to be larger than the angle opposite from the shorter side. And then they kind of reverse it and they say if one angle of a triangle is larger than another angle, the side opposite from that larger angle is longer than the side opposite from the smaller. Okay, but I think it makes more sense to just summarize this way. In a triangle, the shortest side is opposite the smallest angle, and the longest side is opposite the largest angle. But I think this is just an easier way to state this. Okay. In a triangle, the shortest side is opposite from the smallest angle, and the longest side is opposite from the largest angle. And then the ones in the middle are, opposite from each other as well. Let's use those to do some examples here. So in an example where we have the angles in a triangle, I should be able to list the sides in order, in this case from shortest to longest. List the sides of this triangle in order from shortest to longest. Now I know the shortest side should be opposite from the smallest angle. I notice the smallest angle measure is angle T. I look at the side opposite from it, so I know that side RS would be the shortest side. The next largest angle is angle R at 39 degrees, so the side opposite from it is the middle length next largest or longest side. And the very longest side will be opposite the very largest angle, which is angle S, so RT is the longest side of that triangle. Or let's look at the reverse of that. List the angles of this triangle XYZ in order from largest to smallest. Well, okay, the largest angle should be opposite from the longest side. It looks like the longest side here is XZ. The angle opposite from it would be angle Y. That is the largest angle. The next longest side is 11 with side YZ. So angle X opposite from it is the next largest angle. Finally, the smallest angle will be opposite the shortest side, which is here at 8, and so angle Z is the smallest angle. Okay, so we can use this to list sides and angles in order, largest to smallest, or vice versa. You should also be able to do your own sketch and label correctly, because now that we know that an angle, or largest angle, would be opposite longest side, we should be able to sketch and correctly put in lengths and angle measures in a triangle. So here I see that 3 wooden beams will form a brace for a wall. I'm assuming we got a triangle here. The bottom edge is 8 feet. The sides are 12 feet and 14 feet. Actually, I should be able to kind of make that triangle now. I know all 3 lengths. Bottom edge is 8, sides are 12 and 14, so both longer than this. 12 and 14. So maybe I'll do right about here. And I think that would be pretty good. 8 feet. Sides are 12 and 14. 12 feet, and this one's a little longer than that at 14 feet. Okay. Now it says one angle measures 86 degrees and another angle measure is 35 degrees. Correctly sketch and label the triangle. The only thing is, I only have 2 angles, so I should probably figure out what is the missing angle measure, right? I only have 2 of these. So one angle's 86 degrees, one's 35. It's hard to tell what the largest or smallest angle is if I don't know the last angle. So I'm going to find that missing angle measure. So do, 180 minus what we have there, minus the 86, minus the 35. The missing angle measure is 59 degrees. All right, that helps me out. Now I know that the missing angle measure was the middle angle measure. So where am I going to put the 86 degrees? That's the biggest angle, should be opposite from the longest side. The longest side was 14. The 86 degree angle goes opposite from it right here. Actually, that angle looks pretty accurate. The smallest angle was 35 degrees. That should go opposite from the shortest side. Shortest side was the 8 feet. Opposite from it goes the smallest angle of 35 degrees. And this missing angle that I had to find, 59 degrees, was the middle angle going opposite from the middle length side. Alright, so we can correctly sketch and label triangles too. So first we're using this fact that the opposite side, the longest side, biggest angle are opposite, shortest side, smallest angle are also opposite in a triangle. And we're looking at something else today too, is looking at whether 3 lengths can even form a triangle. Could side lengths of 3, 5, and 10 form a triangle? And look specifically at these numbers, 3, 5, and 10. And some of you are thinking, why couldn't they? Would it matter? We can pick any 3 numbers, they'll form a triangle, but is that really true? Do any 3 numbers in the world make a triangle? 3, 5, and 10. Okay, maybe I'll exaggerate a little bit. What if I told you, could side lengths of 1, 2, and 100 form a triangle? Wait a second, 100? That would be a length of 100. 100 what? I don't know, but here's a length of 1. Here's a length of 2. Can this make a triangle? Well, wait, there's got to be some limit, right? I mean, if you have this huge long line, there's no way that sides 1 and 2 would meet with the number 100. So what about 3, 5, and 10? If I knew that this was a length of 10 inches, 10 centimeters, 10 whatever it might be, well, I know that a length of 5 would be half of that, right? So if I go out this way, what do you say? That's about half, right? There's my length of 5. We're trying to make a triangle. Well, wouldn't length of 3? 3's not going to go halfway. 3's probably only about that long. So is there any way that these could form a triangle? Well, no. The 3 and the 5 are too short. They're not gonna reach. Okay, they're not even gonna make that full length of 10. So no, because in this case, if you think about like what we're gonna have to do, if you add 3 plus 5, that equals 8. Less than 10, so they can't even reach that length of 10. If you think about it, even 5 and 5 exactly, that would be like 5 and 5 right on top of the length of 10, and that would exactly equal 10. Well, that's not going to be a triangle either, because it would be just a line on top of a line if it was exactly 10. So when you add these 2 sides, it's got to be more than this side, doesn't it? Like 6 and 5 would work, because 6 would reach past and would be okay. 6 and 5 greater than 10. And this is a theorem here, it's called your triangle inequality theorem, is that the sum of any 2 sides of a triangle, always test the shortest 2, it's the only one you have to do, has to be greater than the length of the third side, or the longer side. Now sum, of course, tells you to add. If you add the lengths of the 2 shortest sides in a triangle, it has to be greater than the length of the longest side, or that third side. And really it is any 2 sides, but this is the only one you need to test. So add the shorter 2 sides, make sure it's greater than the longest side so that they'll actually reach when you put them on the ends of that longest side. So let's practice using triangle inequality theorem. Which of these side lengths could form a triangle? Let's say I have side lengths of 12, 8, and 5. I say, well, 12 is the longest side, right? So the question is, would 8 and 5 be able to form a triangle with that longest side length of 12? Well, 8 plus 5 is 13. So if that's more than that side, yes, we will be able to form that triangle because that'll be greater than that shortest side of 12. So yes, these will form a triangle. I tested by adding the shorter two sides to make sure it exceeded the length of that longest side, and it did. What about here? I have side lengths of 6, 11, and 6. Will these three sides form a triangle? Well, the longest side in this case is 11, so I need to check, do the shorter two sides, 6 and 6, those add up to 12. Okay, well that is more than that side, so they definitely will reach. It will form a triangle in this case because the shorter two sides added together exceed the longest side. I'm also going to do this one here. How about sides of 1, 2, and 3? The longest side in this case is 3. So the real concern is, do 1 and 2 together exceed this longest side? Well, 1 and 2 together when added is 3. Wait a second. 1, 2, and 3? That would be like a line on top of a line, wouldn't it? If this is length 3, this would be length 1, and like this would be length 2. Well, that's a line on top of a line. This has to be more than 3. So in this case, no, this would not make a triangle. It'd be a line on top of a line. I want you to do these last two, have the answers ready for class time tomorrow. Alright. And this last example is definitely the trickiest. You have two side lengths given for a triangle. So a triangle has side lengths 11 and 15 for certain. Describe the possible lengths for this third side. So I have 2, and I want to describe the possible lengths for the third side. There's a range. Okay, there's a shortest number that you can have, and there's a longest number that you can have for this third side. And it goes off of 2 cases. So first you have to think, what if 11 and 15 were the shortest 2 sides, and we're looking for, like, where is the limit for how long the longest side could be? Or the second case is, what if the longest side is already here? What if 15 is the longest side, and it's 11 and whatever for the shorter 2 sides? So, think about this. If 11 and 15 were the shortest sides, that means we're looking for this longest side. What's the limit there? And we have 11 and we have 15. And what about that? Well, in this case, wouldn't we add 11 and 15 to see the limit for the longest side? And that's 26, right? Now that would be, if 11 and 15 were just literally laying down and forming on top of this line, this length would be 26. But that's not okay, because 11 and 15 exactly 26, right? That would be a line on top of a line. So you're thinking anything past 26 is not okay. If it was 27, 11 and 15 would be too short. It would not meet with a big side of 27 being right here, or 28, or 29, or 30, or anything larger than 26 would not work. So it has to be shorter than 26 if you think about it. 25 would work because 11 and 15 is more than 25. It could even be 25.999, but 26 would be the limit. So it has to be less than 26 would really be the case here. But here's the second scenario. What if 15 is the longest side? What if we have the side of 15? Remember, we already have a side of 11. So we have the side length 11 as well. Then the question is, what about this side? Now, what number would exactly add up to 15? Well, that would be like 15 minus 11, right? And that would be 4. Now, if this side was 4, though, 11 and 4 is exactly 15. And remember, that's not okay either, because that would be line on top of a line. And if this was only 3, 11 and 3 would be 14. Oh, wait, that's not going to reach for 15. So you're thinking it has to be longer than 4. 5 would work. 11 and 5 would be 16. That is bigger than 15. Even 4.1 would work, as long as it's longer than 4 or greater than 4. So we have a number we have to be greater than. We have a number we have to be less than. You're thinking this unknown side, we'll call it x, has to be less than 26, shorter than 26. And this unknown side x also has to be greater than 4. But you know how to write a combined inequality. We're supposed to be between 4 and 26. So you literally write x in between 4 and 26. In this case, I switched the order of 4 and x, right? I did, instead of x greater than 4, 4 would be less than x. I flipped that sign. And this is exactly the way it's written. X is less than 26. Your final answer is that that side length has to be between 4 and 26. Because it had to be more than 4 to exceed 15. It had to be less than 26 in case 11 and 15 were the longest sides. Now it seems like a lot of work went into this. Realize all we did was first we added the two numbers and said it had to be less than that. Then we subtracted and said it had to be greater than that. And we wrote it as a combined inequality that that side length is between 4 and 26. 4 is less than x is less than 26. Alright, so have those two problems done, deciding whether it can make a triangle. Talking about triangle inequalities today.